Characteristics of trigonometric functions. Now in this set of videos we'll try to understand what is amplitude, what is phase shift, vertical translations, time period of a sinusoidal function. Well, cosine is also a sinusoidal function. The only difference is cosine starts with the maximum value, whereas sine starts with 0. But effectively they are similar periodic waves because cosine can be seen as a wave shifted by 90 degrees, right? The general. Now, so characteristics for both are kind of similar. Now here we are with the first question, which says complete the table below, and we have two equations here just to give you a variety. Now equation number 1 is y equals to 3 sine 4x, and you need to find what is amplitude, period, phase shift, and vertical shift. For the second equation, the equation is y equals to 3 over 2 cos 2x minus 30 degrees, and you need to find amplitude, period, phase shift, and vertical shift. Now in these set of questions, those of you who know this they should write down their answers and then look into my solution. And for those who are seeing it for just picking it up, and for those who are not very sure about the answers, I like them to make a note while they go through the video so that they remember and retain it. Now in general, a transformed sinusoidal function can be written as, let me write that general equation here, as a times a is the vertical stretch which affects the amplitude, and function f I'm not writing sine or cosine. This could be sine or cosine in our context, right? K times x minus p plus q. Now that is the general equation of our sinusoidal function. Now here a, the absolute value of a is normally the amplitude, okay, and the period is reflected from the k value. Now we can find period by dividing 360 degrees by this value of k, and we get the period here. Phase shift is directly p, right? If this is if you write minus 20, it means phase shift is 20 units to the right. But it could be, if this is plus, then be to the left. So it will be minus of that. Now q is the vertical shift. So from equation, you can directly write down your values, correct? That is so simple as that. But it's kind of very, very important, because if you don't know how to read an equation, then you can't really do much with it, right? Now, we can now read these values directly and write down our answers. 3 is my amplitude, right? So let me write 3 here. Period is, now the value is k here for 4. So the period will be 360 degrees divided by 4, which is 90 degrees. So our period is, or the time period for a wave when it repeats, is 90 degrees. Now that also means when we write 360 over 4, then in 360 degrees we have 4 sinusoidal waves, right? That's how you get sine 4x. So that is what k reflects. K reflects the number of waves within a period of 360 degrees, one full circle, right? Phase shift. Phase shift is this value, which is 0 from here, right? You can write this equation like this: 3 sine of 4x minus 0 plus 0, right? Just to make it equivalent. And you see, well, phase shift is 0 for us, and the vertical shift is also 0, right? That means the axis of symmetry remains along the x-axis, correct? Now look at the second equation. Y equals to 3 over 2 cos of 2x minus 30. Now in this equation you'll find a difference, and that is the purpose of writing this equation here. You see, k value is not factored, and therefore it is always a good idea first to factor and rewrite your equation. 3 over 2, and let me change this equation a bit. Let me write a minus sign here, right? Let me write minus here. Cos of, so I'm factoring 2, and when I factor 2, 30 gets divided by 2, and I get minus 15 degrees, correct? So that is what it is. Now here also you will notice that the vertical shift is 0. So let me write plus 0 here. Okay, no harm. We're just trying to compare and understand at this stage, right? So that is a good beginning. So whenever you try to understand, even if you know about it, it's better to start fresh and get all the concepts in line. Now here, I just purposely put minus because I've seen students sometimes writing amplitude as negative value. Amplitude is like a distance, how much away the function can go from its mean value. That is what amplitude is. So, to give you an idea, let's say this is your sine wave, right? Let's say this is your sine wave. And the axis of symmetry Q is here. I'm not drawing x-axis or y-axis here, right? I'm just drawing a sine wave in general. So this kind of helps us to understand. Then Q is this center value, this value wherever the wave is. So that is Q, right? And that maximum is Q, and that is A. A is the distance you can go away from Q, whether you go in this direction or in the other direction. But it is a positive quantity going away from here, like a distance, right? Not displacement. It's a scalar quantity. So when you go away, you'll also notice one thing. Maximum you can go up to Q plus A, right? So Q plus A is normally the maximum, and the minimum is Q minus A. And that is an additional learning from here. And the time period is actually the period for one full wave, here to here. That is the period we are talking about. And phase shift is normally, your sine function will start from 0, right? But it may not do that always. If it starts with some other point, for example, if I draw my axis here, for example, then the sine function started earlier. So this will be positive 90 degrees. Here, equation, right? Positive 90 degrees. It started earlier, right? If it starts later, let's say x-axis is here and starts there, that means it'll be x minus, let us say, 45 degrees, right? That is how you have to see your questions, correct? Now, let's get back to the problem. So 3 over 2 is your amplitude, the absolute value. So it is 1.5. I can write 3 divided by 2. And as you can see now, time period is, there are 2 waves in one full cycle of one full circle. So it is 360 divided by 2, which is 180 degrees for you. And phase shift is 15 units to right. We can write that like this also. Vertical shift is 0. Okay. Now, as an exercise, what I would like you to do is that find maximum and minimum for both these waves. That is your problem, practice problem. I should call this as my question 1b. Okay, so that is my question 1b. For these 2 waves, figure out what is the maximum and what is the minimum of the function, right? So we'll have another question like this, and I'd like you to answer the question number 2 before my answer. That means you can stop the video, answer the question, and then move on. You'll learn faster and better. Thank you and all the best.